Today's been like the most stressful day in ages.
I walked from Watkins down to here to attend the math test.
I'm proud of you. Right. Is that projecting yet?
Yes, it is.
Is it projecting my image?
It's searching for your. Maybe you want to change the.
I am changing it. The cable.
No. Lady.
Hello!
How does it go?
Alright, class is over.
Hey! So what on earth did you just do?
Because this one's like half black.
Sit down. Just sit down.
So then go
sit down.
I'm just trying to help.
What?
What?
Let a real man fix it.
I'm changing my agenda.
Oh my goodness. Right, now that diversion's over, we'll have a look at finishing stationary waves. We're still missing Fuang.
She's not coming at all.
It looks like it at this rate, yeah.
She messed with the group.
Oh, you need to see this. You'll be a really proud. No, I deleted it.
What? What?
I did that.
Why? You shouldn't.
What?
You shouldn't delete. Shouldn't delete.
What?
No. Turbo.
He's all
He
grown
came
up
out
now.
of his shell.
Wow. That's amazing. Can you actually email that to me?
She told me that she caught today.
This is like crimes against humanity or something type of stuff going on now. Is she torturing him as well? Waterboarding or something? Alright. Yeah, we're looking at something called harmonics. Right, so we're continuing here and then musical flute next. Okay, so a little bit of terminology here. This is when we're dealing with waves that form on something like a string. So this one here, this is the biggest wave we can make. And we call this the first harmonic, or sometimes called the fundamental. What's happening is we're making the wavelength smaller to fit in more waves. So the next biggest wave we can fit in is this one. The reason we're restricted is because we must finish on a node. On a node, because the string is tied at the end. So in this picture here, there's one antinode. And here, how many antinodes? Two antinodes. And here, three antinodes. Is it? Yeah, 1, 2, 3 antinodes, and so on. So these are harmonics. Now, I think it's a bit unfortunate because I think sometimes in some books they call the first harmonic the fundamental, and then the next one they call the first. I'm not sure. I have to double check what they do in the exam. I don't think they use the word first harmonic in the exam. I think they say fundamental. Anyway, if they say fundamental, it's quite clear. Fundamental can only mean the first one. Yeah. So obviously, if the question said what is the fundamental and what is the first harmonic, it doesn't mean what is the fundamental and what is the fundamental. So obviously, if they said what is the fundamental and the first harmonic, then they mean this one and the next one. I will check for you what they do in the exam, but I cannot remember right now because I'm having a stressful day. But you will know before the exam. Just remember to ask me as well in case I forget, because I will forget. Alright. But either way, if you can write this down. Now there's another diagram that's like this when we're dealing with a different musical instrument, but this one is for like strings. Yeah. The way you can remember as well is the number of antinodes in this picture.
I didn't write anything on the paragraph on the previous page.
Nah, because it was only leading into this diagram. This is a pretty nice room. Hmm?
That's big.
Yeah, no, the school could not justify having a room this size for 7 students. Huh?
Then it's empty.
We'll take it. But the only time we have it booked is this time. I think there's other classes in Griffith.
Yeah, but like it's empty parts of the time.
Is it? Okay.
Yeah, Griffith is quite small.
Well, it's all relative compared to what, you know. Okay, do you have this drawn?
We were 1 day behind last year.
Yeah,
But it's not last year.
yeah.
We did this yesterday.
Or your teacher made changes to the file yesterday and the date was updated. Okay, can I continue, please? Yes? Right. What? Right. Now, you can get sound in a musical instrument using air instead of a string. And when a sound wave forms in a pipe, there'll always be a node at the closed end and an antinode at the open end. And I'll draw that to show you exactly what I mean. And this is how you can make musical notes. The pipe resonates or vibrates at these harmonics. So, what I mean by nodes and antinodes here, if you had a pipe, oh come on. For the exam, there's 2 situations. The pipe is closed at one end and open at the other, or it could be open at both ends. I think it's worth writing down where this loads. Closed makes node, and open makes antinode. If you can make note of that. Closed makes node and open makes antinode.
This is for...
Oh, this is for like sound waves in a pipe.
I think if your laptop raises turbo, it might have a chance.
Leave me alone, Faisal. Well, you know, You know what, I don't need to draw it because I have a picture here anyways, which I was going to draw. So this is what I meant by nodes and anti-nodes. So you see these pipes here, they're all closed at the left and open at the right. When a sound wave forms inside this pipe to make a musical note, it's always a node at the closed end. Can you see that? And it's always an anti-node at the open end. But when the pipe is open at both ends, you have a node, an anti-node at the left and the right. Can you see that? Anti-node, anti-node. Anti-node, anti-node. Now there's some other vocabulary I wanted to introduce here. We have harmonics, but we also use this word. We don't use this in physics so much, but it comes in, if you ever studied music, they're called overtones. So usually if we call the first one the fundamental, then the next one we call the first overtone. But with harmonics, usually we start counting here. This is called the first harmonic. So do you notice how they're off by one? This is why it can be kind of confusing in the exam, which one is which. I've never seen them use the word overtone in the exam, so you don't need to write overtone down, but you do need to write harmonics down. And another name for the first harmonic is the fundamental. Okay. Now, it's a bit of a pain to try and draw these because you notice in these situations when they're open at both ends, you count up in ones. 1, 2, 3, 4, 5, fifth harmonic. But in this situation when it's closed at one end, you don't have even harmonics. You only have odd harmonics. 1, 3, 5, 7, 9. And the reason for this is because it has to be an anti-node here. It's almost like the ones that have the node at the end you skip. So for example, in this picture, this is one way you can get in. Yes? The next one would look like this. It would have a node here, and then finish on a node. But we can't have that. Why not? Because it's open at the end, it has to finish on an anti-node. So it's like we skipped the second one. It's not possible. And we skipped the fourth possibility and the sixth possibility. Okay? This is a bit hard, but the good news is in the exam, often it's this one that they ask. So when it comes to memorizing for your notes, make sure you give more priority to remembering this one. And anyways, I think this one's easier to remember because you count up in ones. Yeah. Also what's useful to note is the wavelength. So you see here, it's a quarter of the wave that fits in. Because what would happen is the wave would continue down and then go underneath. Can you see here? It's 3/4 of a wave. The last quarter is cut off. In this one, you have 5/4 of a wave. You see that? Yeah. So one way you could remember which harmonic you're on in these one is how many quarters do you have. So in the first one, how many quarters of a wave do you have? 1. So we call that the first harmonic. How many quarters here? 3. We call it the third. Okay? So this one goes up in quarter waves, and then how much does this one go up in? Half waves. Yeah? So this diagram, or at least how to draw this diagram, you must absolutely know for the exam on the wave question, because they will sometimes even ask you to draw, for example, the third harmonic in a closed and open pipe. Closed at one end, open at the other end. Okay, so please draw this very carefully in your notebook, and it'd be great if you can write all the words down as well, Lee. Yeah? Okay. I'll be back in 2 minutes. I need to go to the bathroom. Don't go anywhere. I can trust you. Did you send the turbo's picture?
Yeah, just now.
I think I might make it my new background on my laptop.
I'll get you a better quality one with my camera number 6.
And you have your laser? Please.
He said that I can take pictures.
Hmm?
It's a drug, not a picture. Easy.
Drog.
Look. Look what Romans do. حب العيال. Wow, I have 3 new friends. No, Ali, don't do this.
Okay.
He's looking at the book. Take the better one.
Okay, put the paper. How can you do that?
Good.
No, don't get instead. Okay. Neat. You don't know? Definitely for
What? I have 4 new friends.
Right, did you draw that? Yes. Okay. So I think, yes.
When you're playing on a pipe or a flute,
Yes.
and you close and open the
Yeah,
hole,
I think you're...
are you making an antinode where you open a hole?
I don't know exactly. I have a feeling you may be changing the length of the pipe in a way.
The wave, you mean,
Yeah. Yeah, that you're creating an antinode.
when you open a
Open
hole.
it, yeah. But I think it's probably a bit more complicated than that, because this is a very simple musical instrument that has no anything. It's just a pipe. So it's almost like a glass of water that you strike to make a note, or wind blowing in a pipe or something.
When we start with fundamental, then we jump to the second, not we repeat the first harmonic,
Fundamental is the first harmonic, yeah.
and if we start with fundamental, then is first harmonic the second harmonic?
No, fundamental is the same thing as the first harmonic.
So second harmonic remains second.
Yeah, yeah. Okay, continue. Did you draw that? Yep. Right, so let's see, we'll have a look at an example now. A boy ties a rope against the wall and stands 2 meters from it. He vibrates the other end so that a first harmonic stationary wave is formed. What is the wavelength of the formed wave? 4 meters, yeah. So the first harmonic wave in this situation is, well, it could be 4 meters or it could be 8 meters, depending on the boy's motion of his hand. So like, if he's holding it like this and flicks it, then he's formed a node and a node, and you'll have half a wave inside. But if he's moving his hand up and down, then he could be forming a quarter of a wave. So the situation is either, here's the wall, and here's his hand, and in this case, what would the length of the wave be? That would be 8, because it's only a quarter. But if the situation is like the string earlier, where you have a piece of string and there's a wave on it, then that's only half the wave, so the length of the wave would be 4 in that case. So there's 2 answers here, 4 or 8, depending on if he's making a node or an antinode with his hand.
So, in a sense, what should you write?
Can I look at the
Oh, the test will make it clear which one to choose, huh?
Can I look at the question?
Yeah.
4 for the
Yeah,
with a closed end,
4, correct, 4 with a closed end, 8 with an open end, yes,
and with an open end is
8. Yeah, so 2 answers here.
8 if he's doing this,
I saw.
closed end.
and 4 if he's doing this.
Thank you for the demonstration. Can you actually turn around, face forward? That'd be great, thanks. Can I go to the next example? A stationary wave is formed in a 17 centimeter pipe which is closed at one end and open at the other end. The wave formed is a first harmonic and the frequency is 500. What's the speed of sound? So the pipe is 17 centimeters long. It's closed at one end, so that's like the pictures on the left. And the first harmonic is formed. So if I draw that, how long did I say it was? Sorry? 17 centimeters. And what's at this end? Node or antinode? Node.
No.
And this end? Antinode. So the first harmonic is this one. The one that's vibrating up and down like this. How much of a wave is that?
Times 4.
How much of the wave is this? A quarter of the wave is equal to 0.17. So that means the total wave, what's that, 68 is it? Please. Do this with calculators, multiply this. Huh? Yeah.
0.26.
Okay. Now, we have to calculate the speed of the sound wave. So what formula could we use here for
V
V?
equals lambda F.
Try again.
V equals lambda.
Thank you. Which in this case is 0.68, and I tell you the frequency is 500 hertz. So what do we get here, please? 330?
40.
40.
Wow. So it's faster than sound.
No, there is an error in this which comes up in a later question. This is a typical section A question on waves in the exam. Do you need to write this down? Yes? Did you write it down already? Are you going to write it down? Possibly. Bus airline drivers. You blankety blanks. Okay, you wrote this down? Yeah, and do you need the question? Yeah. Yeah. Continue. Yeah. Okay. Right. Question time. Please note the speed of sound is 340 for these questions, although I know it's not 340, but for some reason I chose 340. So we can start these now, and then in the class after lunch, we'll do them in class. And then as soon as they're finished, you can, if the class is only half finished, then you can leave early if you want. Okay? So you can start these now, and then I'll give you the answers in the next class.
This is our last topic and
Yes?
so on.
Yes? You speaking English or what? Is that Japanese?
Oh,
No, that's not Japanese, that's Americanese.
yeah.
Right, can you...
Very cool in Japanese.
Yes. You can start these now, please. Please note these are all modelled off of exam questions. Yeah? What? Are you being good? No. Can you start these now? And maybe while you're working on these, I'll test out these speakers and see what we can do.
Stephen, can I just recall one thing you said?
Yes. Oh, sorry, let me stop the video here.